toughest one because what happens in the JEE, they mix the questions, right? Like rotation and rotating and sliding. So both the things like rotation concept and the uh, linear concept, sliding concept, will be used. That's why like it becomes a little bit difficult to analyze the situations,
Okay.
right? And also the pseudo kind of concept, if it will be there, so it will be difficult to analyze in case of rotation, right?
Yes, sir.
That's why the questions are generally considered like if it is straightforward, it's good. If it is, let's say, mixed with the linear motion and the rotational together, then sometimes it's difficult to analyze and like analyze and simplify. Okay. So now let
Sir,
us
do
discuss
you have Physics Galaxy Part 1 book?
Physics Galaxy Part 1.
Yes, sir. Do you have?
No, I don't have the Physics Galaxy. That Aurora, no?
No. Physics Galaxy is different. If you
Not
had, I
Aurora.
would have asked for
That
it.
one, the author name is something like
Yes, sir. Aurora, Ashish Arora, that one. I thought SL Arora you were talking about.
Ashish, na Anish Arora.
Ashish Arora.
Ashish Arora. Yeah.
If you have the book or it is there in school, please, sir, inform me once. I want to read that book once.
Okay. He is running. He is, I think, having a YouTube channel also.
Yes, sir. Then Onion Physics.
Yes. Physics Galaxy.
Yeah. Like some people tell that this book is better, but like in Griffiths, I asked some people like what they are following. There, some people told me DC Pandey, some people told AC Verma. AC Verma is quite okay for basics, but DC Pandey is not good at all. And I listened to them and I bought the books, and I don't think like they are that good for like building up the concepts for JEE.
Okay.
So, let's start with center of.
So is the screen visible?
Yes, sir.
Like so we'll start rotational motion.
Yes, sir.
That is system of particles and rotational motion. System of, so in Akash it is completed. System of particle rotational motion.
Yes, sir. Probably they are done with solid mechanics also.
System of particles and rotational. System of particles and rotational. So first concept we'll discuss, that is center of mass.
Yes.
Center of mass. So what is center of mass? The center of mass, you can think of, if two objects are there equal mass connected through a very or massless thread or massless rod, then if they are same mass, so you can hold at the midpoint and you can both the masses will be like, but they will be balanced and you can hold them, right?
Yes.
So this is called, like, where the masses are concentrated, that is called the center of mass of the object.
Okay, sir.
So you can define like, it is the, what is center of mass? Center of mass, the center of mass of a system of particles, system of particles is that single point which moves in the same way or the center of mass of a system of particle is that single point, you can write single point where whole mass of the body is supposed to be concentrated, where whole mass of the body is supposed to be concentrated for describing concentrated. Now, if these masses are discrete, we can easily identify the center of mass. But if the masses is continuous, let's say plate,
Yes, sir.
the plate is one side less thicker, another side more thicker.
Yes, sir.
So midpoint will not be the center of mass. The center of mass will be somewhere here,
Yes, sir.
right? So in this type of non-uniform objects or the uniform, uh, the object where mass is distributed uniformly, then also we can find out the center of mass. But both the cases, the techniques are different. So for discrete masses, what will be the formula? Now, if there are two masses and this mass m1 is, let's say, from the origin x1 distance, and this mass m2 is at a distance, let's say, x2 distance. So what will be the center of mass between this? The center of mass, let's say x equal to x center of mass equal to m1 x1 plus m2 x2 divided by m1 plus m2. This is the formula for the center of mass. Now, if you take this same mass, let's say m1 and m2 are same, you see that that will be exactly at the midpoint. You can prove that easily. That if both are same, then mx1 plus mx2 by m plus m, that is m plus m, that is 2m. So m common, x1 plus x2 divided by 2m, cancelled out. So simply you are getting xcm for m1 equal to m2 equal to m. If both the masses are same, you are getting x1 plus x2 by 2. That means this distance from origin, this distance from origin. So you will be getting the midpoint between them, right?
Yes.
And we are expecting also the same thing. If both the masses are same, we are expecting that the center of mass will be at the midpoint, right? So if there are discrete masses, so you can do like this. You can do like this, okay?
Yes, sir.
Clear.
Yes, sir.
Audible.
Sir, what did you say for continuous body?
Huh?
Continuous body?
I can't hear you. Your voice is low.
Sir, what did you say about continuous object? I cannot.
I think your voice is too low.
Sir, can you hear me?
Little better.
Network is, sir, very bad. Sir,
Yeah.
I'm saying, what did you say for continuous body? I could not hear that
Yeah.
time.
Continuous body. This is for discrete.
Yes, sir.
Masses are at different positions,
Yes.
separate.
And for continuous?
Continuous body, what we will have to do? We have to integrate.
Okay.
To find the midpoint, we'll discuss for a rod, let's say. We have to integrate and we have to find the midpoint. Let's say
For
this is
some plate.
uniform rod. Yes.
For a plate.
For a plate, or let's say first, let's take one dimension case.
Okay, sir.
Let's take a rod of length L. So exactly at the midpoint, if it is uniform, if the rod is like this, let's say non-uniform rod, so the
Yes.
center of mass will be closer to the heavier part, right?
Yes, sir.
But if it is uniform exactly at L by 2, you will
Yeah.
get the center of mass. Your center of mass will be at the midpoint of the rod. So that's one you can find out using, because here mass is distributed throughout the. You
Yes, sir.
cannot find out that what is M1 and X1. There is nothing like M1 and X1 here. So in this case, you have to integrate and you have to find the center point where
Okay.
right.
Yes, sir.
So this is for one dimension case. Now if it is two dimension,
Yes, sir.
if it is two dimension, then there will be two coordinates, right?
Okay, sir.
to specify its position, let's say this is x1, y1 point. This is x2, y2 point. This is x3, y3 point. Right? This is x4, y4 point. So if the like here the masses are distributed, here it is discrete also, but the masses are on a plane,
Yeah.
not on a straight line. So in this case, what will be the center of mass? Right? So it can be, if all the masses are same, it will be at the center. But if
Yes, sir.
let's say one mass is quite heavier than the other three, so it will be shifted towards the heavier mass, right?
Hmm.
Center of mass will be shifted to the heavier mass. So in that case, we will be finding out. So whenever we'll find out center of mass, the center of mass also will have two coordinates,
Yes, sir.
x and y. It will not be the same, like only one coordinate will not find. So we'll be finding out two coordinates here. So here will be XCM. So XCM will be, let's say this is M1, this is M2, this is M3, and this is M4. So it is M1 X1 plus M2 X2 plus M3 X3 plus M4 X4 divided by M1 plus M2 plus M3 plus M4.
Okay, sir.
Right?
Yes.
And there will be also another coordinate, y coordinate also will be there of center of mass.
It will be y1.
Yeah, so it will be M1 y1 plus M2 y2 plus M3 y3 plus M4 y4 divided by M1 plus M2 plus M3 plus M4. Right?
Yes, sir.
So now let us do one numerical, then we'll come to your uniform case also. These are the discrete. Right?
Yes, sir.
So now let us discuss one numerical based upon that. Let's say that there is a triangle. Let's say there is a triangle, and in this triangle there are three masses are there. This is mass 1, this is mass 2, and this is mass 3. There are three masses,
Yes, sir.
and this triangle is a equilateral triangle, each side 1 meter. Locate the center of mass of the system. Question is, locate the center of mass of the system.
No, it will be with respect to every particle.
Hmm?
Is
So
it?
what we'll do, we'll put a axis here. Let us put and one axis here. So let us write the coordinates of the points. So this one will be 0, 0.
Yes, sir.
This one will be 1, 0.
0.
And this point will be,
1 by 2.
this is the midpoint, right?
Yes, sir.
So this one will be 0.5. X is 0.5.
Yes, sir. 0.5.
Y is the height.
1. No, no, not 1. It will be
Height will be what?
0.1 square, 0.5 whole square plus
Yeah.
1 minus 0.5 whole square.
Yes. 1 minus 0.5 whole square under root. Or it will come
0.75.
0.25.
25.
So
0.75.
0.75 under this. Right?
Yes, sir.
0.75 you can write 0.5
Root 3.
right?
Yes, sir.
The formula for the height is what?
Base
It's
square
3 by 2 into A,
square.
right? For an equilateral triangle, the formula of the height is root 3 by 2A.
Yes, sir.
So root 3 by 2A is here 1. 1 by 2 is 0.5. So 0.5 into 3, root 3, right?
Yes, sir.
So 0.5. So 0.5 and the y coordinate is 0.5 root 3. Just the coordinate we need to write. Else the part, other things you can easily find out now the center of mass. Let's say the center of mass is here, xy coordinate. So our x will be m1 x1, x1 is 0. So 0. m2 y2, m2 x2, m2 x2 is 1. And m1, m2, m3 are also given. m1 is 3 kg, m2 is 4 kg, m3 is 5 kg. So m1, m2, m3 is 5 into 0.5 divided by 3 plus 4 plus 5, that is 12.
Yes, sir.
So m2 is 4, 4 into 1, 4. So 4 plus 5 into 0.5, 2.5 by 12. So 6.5 by 12. So it will be, we'll divide 5 approximately
Yes, sir.
0.54 meter,
Yes, sir.
the x coordinate. So the x coordinate will be 0.5. Let's say this is 1, 0.5 will be half of this. Somewhere here, x coordinate. Now we'll extend it. Now y coordinate, let us find. Y coordinate. Oh, 0.5. Na? So total is 1. 0.54 will be somewhere here.
Yes, sir.
This is 0.5. Just this is 0.5. Just beyond 0.5. Now let us find the y coordinate.
First
So
one will be 0, second M2 also 0 plus
0 plus 0
5
plus
into 5 into
5
root
to
3 by 2.
0.5 root 3 by 12.
Yes,
That
sir.
is 2.5 root 3. 5 into 0.5 is 2.5 root 3 by 12. So you can put the value of root 3. 1.7, multiply and find out the approximate. The approximation should be equal to 0.36 meter. Find
Yes.
out, check. So if this is your y, so y will be, let's say this is your 0.5 root 3. So 0.3 somewhere here, let's say. So this point is your center of mass. And the coordinate of the center of mass, coordinates are x is 0.54, comma 0.36. This is the center of mass of the system which is having three masses at the three corners of the equilateral triangle.
Yes.
Now, instead of giving like in coordinate form, if it is given in vector form,
Yes, sir.
so you can convert to coordinate form or you can directly write also. Suppose the question is like that, given the two particles of masses 100 gram and 300 gram at a given time have positions 2 I cap plus 5 j cap 13 k cap and minus 6 I cap 4 j cap 2 k cap meter respectively and velocities 10 I cap minus 7 j cap minus 3 k cap and 7 I cap minus 9 j cap 6 k cap meter per second respectively determine the instantaneous position and the velocity of center of mass. Determine the instantaneous position and velocity of center of mass. Velocity of center of mass. determine the instantaneous position and the velocity of center of mass. So this vectors is nothing but the point. You can write
Yes, sir.
this is 2, 5, 13, right?
Yes, sir.
So two particles mass, one is 100 gram, another particle mass is 300 gram. Given the position, that means one particle position is 2, 5, 13.
Yes, sir.
The vector meaning is same, right?
Yes, sir.
And the second particle position is -6, 4, -2.
Yes, sir.
So where will be the first, let's say, center of mass position, let's say, find out. Then velocity also there. We'll find the velocity same way. So if two particles are moving, then their center of mass, velocity of the center of mass also will be, also will find out the same way, like we are finding the position. So how will you find this one? This one, same formula. Here three coordinates are there. So we can find x center of mass, that is 100 gram. You can write kg, 0.1 kg into 2 m1 x1 plus 0.3 into -6
Yes, sir.
by 0.1 plus 0.3, right? Similarly, you'll find y cm, 0.1 into 5 plus 0.3 into 4 by 0.4. Similarly, you will get ZCM. ZCM equal to 0.1 into 3 plus 0.3 into -2 by 0.4, right?
Yes.
Then we'll be getting x, y, z of center of mass, or we can write the r center of mass in the vector form, because these two things are given vector form. Suppose whatever the number you are getting for this one, whatever the number you are getting for this one, whatever the number you are getting for this one, you
Yes,
will
sir.
be getting this number with I cap plus this number with j cap plus this number with k cap, right?
Yes, sir.
So this is one way of doing it. Another way of doing it is directly you can use the formula and you will get the same thing. You see this formula carefully and you will see that if you write directly, want to write RCM in form of a vector, so M1 R1 vector plus M2 R2 vector divided by M1 plus M, same result will come.
Yes, sir.
So you can see here we are multiplying M1 with 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 all components of R1.
Yes, sir.
We are multiplying 0.1 with your 2, and we are multiplying 0.1 with 5, 0.1 with, right? So when we'll be adding, we'll be getting the terms. Similarly, we are multiplying M1 with M1 with
M1 with 2. Sir, you are not audible.
yeah. So we are multiplying M1 with
M1 with the first x-axis, that is the 2.
yes.
Or 2 and minus 6 difference.
So here R1, if I want to write expand, if I want if I expand it and write R1, I'll write something like 2ik plus 5jk plus 3kk. That means basically I am writing, you see, if we look carefully and see,
Yes, sir.
that is M2, R2 is my minus 6i plus 4j minus 2.
Minus 2k.
So by M1 plus M2, and this is 2M1i,
Yes, sir.
5M1j, or let us write like this, 2M1i
Yes,
plus
sir.
1, that is minus 6
Yes.
M2z, right?
Again, we'll write a 6
5,
y.
6M, sorry, 6 minus 6 M2i,
Right.
and this is 5M1j
J
plus
plus
4M2.
4m2j
So you
plus 3.
M1 plus M2 I can write like this.
Yes, sir.
Every is the denominator I can separately divide, no problem. So
Yes, sir.
this part is what? Your XCM
The
part.
XCOM.
This part is YC.
YCOM. Then the left out is
Common J will come
ZCOM.
up like this. And this part is your
ZCOM.
ZCM. So M1, 3M1 K plus minus 2M2 K by M1 plus M2.
Yes,
So this is your ZCM. So you can remember this formula.
yes, sir.
So basically this formula and this formula are same.
Yes, this is just a total added version.
Yes. So you can directly, if this type of vector is given, you can directly use this, or basically this is nothing but our base formula in this one.
Yes, sir.
The same way you will do the, because for the velocity center of mass, you will write m into v1 vector plus m2 into v2 vector by m1 into m, m into v1 and m into v2.
Yes.
So you will get BCM.
So will you send some question from SL Aurora of Center of Mass?
Yeah. So BCM also you can write in the same way, right?
Yes. Sir, I have a doubt from Center of Mass. I'm sending you.
Yes.